So in this video, we are going to simulate single stage RC coupled common emitter BJT amplifier using Multisim software. So the first step, you need to install the Multisim software by National Instrument in your PC. So I already installed in my PC. So I will open that Multisim software. So this is the main screen where we have to design our circuit. So first step, now at the top there are different tabs. So we have to go to the first place button. In the place tab, again component option is there, right? So in the component, all the different component are available. So you can choose a different category of that. So first component, I want a transistor. So again in the transistor, the different model transistors are available. Out of that, whatever the transistor, whichever the model number you want, you can choose. Let us consider if I choose this, then click to OK and just click to the screen. It will be placed. The component will be placed. Like that, we have to place all remaining component in the same step. Let us follow the same step. Go to place component. Now I want resistor. That resistor is available in the basic category. So go to basic, choose a resistor. Now here different values of resistors are available. We can place any value. Later on we can change its label as well as the value. Consider if I choose 1 kilo and click to OK button and place it. Now you can change its label and value by double clicking. So here the value is here. The label of this resistor is RC resistor, that is a collector resistor. So the value I want that value as a 3.3 kilo ohm. 3.3 kilo ohm. Click to OK button. Now you may rotate this by right click, rotate clockwise. So you can place according, you can shift this. Again, if you want more number of resistor, once one resistor is placed, you can have just copy, paste. Remaining all resistance, you can paste it. So total 4 resistors I want. Now you can change the value. Double click the value. This value is 33 kilo ohm, and you may change the label. This way we can give the name R1. Similarly, the R2. This is R2. So change its value. The value of R2 is 4.7 kilo ohm. Click to OK button. So R1, R2, RC. Now last one is, this is RC resistor. Sorry, RE resistor, right? That is emitter resistor. Change its value. This value we want 470 ohm. Click to OK. Now you can just join the circuit according to circuit diagram. So here wire, automatically the wire will be there. You can just shift this. Again the base of the transistor should be connected here. Do all the connection as per the circuit diagram. You may arrange this according to circuit diagram. Now along with that, I want capacitor, few capacitor. Go to place, again component. Now here I want capacitor, but electrolytic capacitor you can choose, right? Click to OK. I want three capacitors. This is one capacitor. We can copy, again paste. One more capacitor. So this is coupling capacitor 1, this is coupling capacitor 2. The value of coupling capacitor 1 is 10 microfarad. So you have to give the proper value of the all the components. This is also 10 microfarad. and this we can rotate according to circuit diagram. Now its value is 100 microfarad. Okay, now just arrange this coupling capacitor to, again this is basically bypass capacitor. We may change the name of this capacitor as a CE capacitor. We can change the label CE, that is the capacitor parallel with the RE resistor, right? Okay, now the remaining connections we need to give the biasing voltage. So again go to place component. Now here we have to go to sources, right? So which type of source I want? VCC. This is the voltage, and this value, I want that value 12 volt. Okay. Now one more thing, please, ground, very important is ground, that is also available in the same category, that is source. Click to ground, okay, and give the ground connection. That's it. So this is the circuit diagram completed, but the remaining for testing we need to give the we need to connect the instrument. The first instrument we want, that is a function generator for giving the input signal that we want to amplify. So if you see this screen at the right side, there are if you just go to and we'll find so many different type of instrument. So select the function generator, click here. Now do the connection. See, the connection will be this positive, we have to connect through the coupling capacitor one. This middle part we have to connect to the ground, and set the proper value of the function generator. This frequency I want 1 kilohertz, and voltage, see the BJT is a small signal amplifier, that means we have to give the small signal, that is which is in millivolt. So I can choose a 25 millivolt, that means V peak to peak will be 50 millivolt, right? So you have to choose this value, and whatever the shape of the waveform you want, you can choose that. Here I have selected sine wave. Okay. Now for this is a source instrument, right? So with the help of that we are giving the input signal that we want to amplify, and the output, in order to observe the output we want oscilloscope, right? So choose the oscilloscope. So you can just, this is oscilloscope, right? Drag in, click it. Now there are the two channel A, channel B. You may give the input signal to channel 1 or channel 2 and output signal to. If you are giving input signal to channel 1, you can give the output to the channel 2, right? So let us consider, if I am using this A channel for the input waveform, in order to observe the input waveform, and this positive will connect to coupling capacitor 2, and one more thing, this we have to ground it. Common ground we can give. Again we can copy this ground and give it here. So the circuit diagram is now completed. So in order to run this, there is a simulate and run option, or the shortcut. Here also the run option is available. So click to run button. Now where we have to observe the waveform? On the oscilloscope. Double click to this. Now first of all, one more connection, just close this. See this wire, we can change the color of the wire. Click to right. First of all you have to stop this wire color segment. You can see why we are changing the color of this wire. You may change the input color wire also, in order to observe, differentiate the input waveform and output waveform, right? Once again run this and click. Now first of all, this screen we can reverse it by clicking this reverse button. Now we need to adjust this time per and hold per division, right? So this blue color waveform is our output waveform and red color is input waveform. right? So just make it proper so that it can visible properly. That's it. Okay. So this red color is input, right? And blue color is output. So basically in this screen oscilloscope, this is a time per division and channel 1 and channel 2. In channel 2 we have connected the output waveform, that is a blue color waveform. Now the first observation is the input and output waveforms are 180 degree phase shifted. So already we studied its theoretical part, we have covered, that is why it is 180 degree phase shift in case of common emitter, right? So the first observation is right, that is input and output signals are 180 degree phase shifted. Now the second thing, the second parameter we have to find its voltage gain. For that we require the output voltage and input voltage, right? So normal setting, first click to AC button, AC mode, single mode, right? Now how to find the output voltage value and input voltage. Input voltage already we know, that is from the function generator, that also we can cross verify, and the main thing is output voltage. Now for that, here the two cursors are there. This is blue color cursor 2, this is cursor 1. So you have to arrange on the blue color. See, just click to the blue color waveform and just see this cursor 2 have kept at the maximum peak and this cursor 1 I have to keep to the minimum peak. Now I arrange the cursor like this. So this value T2 minus T1, this value we have to note that this value is 9.045 volt. This is our output voltage. Whereas what is input voltage? That is 50 millivolt peak to peak, or you can say 25 millivolt peak value. So if you do the calculation for the voltage gain, the voltage gain is output voltage upon input voltage. The output voltage is 9.045 divided by the input voltage is 50 millivolt. Here we have considered peak to peak voltage. So if you do the calculation, then you will get 180.9 value. The voltage gain for this circuit is 180. So the gain of this circuit is 180. We'll see the next part, that is the next parameter, that is we have to plot the frequency response. So in order to plot the frequency response graph, we can close this. Now there is another steps to plot the frequency response. Why we are plotting frequency response? In order to find one of the important parameter, that is bandwidth. In the first step we have calculated the voltage gain, that is about few hundred, that is 180, and we'll find now the bandwidth of this circuit. For that, so first of all you have to go to simulate. So first stop the simulation, then click to simulate, go to analysis, in that AC analysis. Now the frequency parameters. So this is the start frequency and stop. You have to give maximum frequency, which is already here. By default it is in gigahertz. Start frequency is hertz. That means the start and stop, we have to start is minimum 1 hertz, maximum we have to give it is in kilohertz, and it is already by default 10 kilohertz. And here sweep type, here we have to select it decade. The number of points per decade again 10. Now here instead of logarithmic, you have to click to decibel. So these are the setting for the frequency parameter. Now click to the next tab, that is output. Now see the output. So in order to find which is output node, so we can just click to this wire and go click to property button. So here net name is 5, that means this is a node 5. So again I am repeating the steps. Go to the simulate, analysis, AC analysis. The frequency parameters already we set, but here decibel we have to click to vertical scale in decibel, because mostly the voltage gain we are measuring in dB. Now the output,